All right. What I was about to say is I fully agree that idiosyncrasy or different perspectives on learning are really important. I've only come to realize this in the past few years, I think, in that, the more you learn or teach yourself or things you read, the more you realize, like you read 5 books on a topic and maybe the first four don't click. And then the fifth one, for whatever reason, you cannot even point it out. You cannot even say, oh, this does, whatever. But it's just a slight shift in perspective that this book gives you, and that suddenly makes things click, right? Recent example, this week, I was trying to learn Flexbox, just out of curiosity. So I tweeted about this a couple of weeks back, and people were sending me all of these links, and they said, look at this, try this, read this. And they were all, you know, the ultimate guide to Flexbox, the Flexbox cheat sheet whatsoever. And everybody was saying, I swear by this, and they were all different. So I read through, I think 3 or 4, and the first two, oh yeah, I think I'm starting to get it. But then the third one was this interactive tutorial, and they just explained it in a way that immediately clicked with me from, I don't want to say first principles, but where others, for example, they kind of skipped over the names. They said, oh, this is justify content and this is align items and this and this does that. But the third person, they were like, this is called this because here's the underlying mental model. This is called this because of so and so. And that just made it click for me. And it's, again, 3 different people having the same goal. I'm going to explain Flexbox once and for all, ending up with completely different explanations. And now, thanks to the internet, I can flip through, the teachers and can see which one clicks for me.
So do you think
And
if you had landed on that third one right away, would that have been sufficient? Or was it you were sort of introduced to a few different ways? You knew the
good point.
terms. Yeah, it's
Good
interesting.
point. I think the third one was, um, I think, yeah, I would have gone further with if I had started with the third one. And that's because it's just, sometimes you read something, and while reading, you have these questions pop up. What does this mean? What does this mean? Blah, 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 blah. And then sometimes you read something, and every time a question like this pops up, the author answers it in the next paragraph.
Hmm.
And it's just, I think it's, some minds work like this and other minds work like this. Some person needs a comparison to math. Another person needs a comparison to physics, something else. And for me, it's basically, I don't know, specific way of explaining things from the ground up, I guess.
It's funny that you mentioned Flexbox specifically in this context because I feel like weirdly, Flexbox is like just this really rich domain of people exploring different ways of explanation.
Yes.
Like there's Flexbox Froggy, there's like a
Yeah.
Flexbox game that you shoot zombies and stuff. And then obviously people try to write the one definitive Medium article. It's just like people are going to study Flexbox teaching as
Yeah.
a kind of pedagogical vein.
So can
But
you,
yeah,
at
like
this
people
point,
come from different.
I was gonna say, can you center a div now?
I think I could look up how to do it. I think I
Okay.
think people say this is how you send it a diff. I think I could look it up now. Yeah,
So,
justify content center. I don't know, something.
Yeah.
so did you have this kind of feeling while you were writing your books? Like, did you feel like you needed to express your way of teaching this subject matter to a particular kind of audience, or were you trying to make the one true, text in this field?
The first one. I think, I'm looking at these books, Apple, Modern Compiler Implementation in ML, Engineering a Compiler, what else? Dragon Book down there. I think whenever I read them or try to read them, and I haven't read the Dragon Book, just bits and pieces. But whenever I tried to read it, I just couldn't get into a groove where I thought we're on the same wavelength. It was always, I'm missing something. Something here does not add up. Why do we do this? What's important? What's the ultimate goal here? Why would this be a thing. And I found that there was a lot of other resources, blog posts, tutorials, as you call them, that were completely opposite end of the spectrum. And they would explain, let's build a little toy interpreter, let's build a little toy, language. And the goal was clear. The goal was, let's build this. Look, we can type in 8 times 4, whatever, plus 3. Look, how it uses the operators and whatnot, and the correct result comes out. But I was missing things in the middle that explained, here's what we want to do. Here's why we do this to reach this goal, and here's how to do it. And to give you a concrete example, there's this, I can't get the full title. I can't remember the exact title, but I'm sure you know this paper. The one paper, what an incremental approach to compiler construction, building a scheme in x86, something. It's only 4 pages where, the author explains how to build a little scheme compiler in Scheme, obviously, in just 4 pages. And they were saying, you just start with the primitives, you move this in register, now we have numbers, now we do this. And online, everybody was saying, read this paper, this is so simple. Build a scheme in Scheme, build a scheme to x86 compiler in Scheme, so simple. But I was reading this, and it was just, every little paragraph felt to me like the meme of draw the rest of the owl. Like, oh yeah, you want to do numbers? Just move the number into the register, you're done. And for me, it was, what? Now we do strings. And then it would, for example, say, actually, I don't know if it says this specifically like this, but it would say, we have to allocate them on the heap, right? And I would sit there and go, why do we have to allocate them? Why do we have to do this? So then I found another resource where a person was implementing, like they had a full implementation of this paper, like the full code, and not just the snippets and like the brushed off, fill in the details, but the full thing. And just reading through this and comparing it, I could suddenly, make sense and see, so this is why you do this. Okay, if we have this is what they meant with that. And I had many of these experiences, and I thought, wouldn't it be great if somebody took all of the bits and pieces and, without saying, let's skip over this or let's skip over that, just compiled them in a straightforward way and put it in a resource like a book or tutorial or whatever. And yeah, I guess that's what I did. And now looking back, it's been it's been 8 years, Jesus. But it's been a while. But looking back, I realized that even when I was 14 years old, I was writing tutorials on online, forums, like how to use, for example, I think the first one I wrote was how to use Screen on a Unix machine, the precursor to Tmux, and like all of these tutorials. And I always loved this approach, here's what we want to do. And back then, common thing was Photoshop tutorials. Everybody had their pirated copy of Photoshop 6. And then, you want to use this, here, you want to do a logo like this. Here's how you do it. And it's step by step, nothing left out. And then you could basically follow up, and you could go on side quests and find out why certain things work the way they want. And when you follow step by step, you always have the option to pause and kind of explore on your own, right? You're in step 6 of 10 doing something in Photoshop. You can just continue and play around and, fiddle with the controls and see what happens. So I'm saying this because looking back, it seems like maybe one thing led to another, like even 15 years later, but that I really like this style of learning, this show me something and feed me enough information to help me along, but leave me room to find my own, to pull in more information as I see fit.
Yeah, to me, it feels like leaving those breadcrumb trails that you can go down, the sort of text that you're going, that 4-page thing, it didn't do enough in that regard.
Yeah.
And you also, I feel like there's a failure mode where it explains literally everything, and you don't get to explore it on your own. And I think, Aj, you do a really good job of advocating for people to say, like, when you come to a point in a textbook, you should maybe like put your hands over it and block and think about what it's going to say next rather than just reading the full thing. Because I know I did this great book, How to Make a Dungeon Crawler in Rust. And I went through the whole book and I had an awesome game at the end. And I don't know that I don't certainly don't remember how to write Rust. And this was like 2 years ago or something like that. And I think I was I wasn't going on the side quests enough. It was just, oh, I want to make my character do X, Y, and Z. And I sort of linearly went through it where I wasn't really doing that recursive backtracking. I wasn't going on the side quest because I was just flipping through and making progress. And I don't think it stuck. It did not stick.
Yeah. I
My
think,
favorite example of that is Balaji Srinivasan. His approach is to just do the problems at the end of the chapter before looking at the chapter. It's like, I've got a textbook, it's got exercises, whatever problems at the end. I'll just attempt the problems. Maybe I'm going to figure them out, and maybe like I can skip reading the chapter if I do that. Or maybe I'm going to figure it out and then look at how the author suggests doing it. Or maybe I'm not going to figure it out, but that's going to motivate me to actually go through that material. And now I know that this is what I'm going to be able to do at the end, like, because I've made an earnest attempt at that already. And, you know, in terms of like picking up different areas of particularly science in his case, he was just like a machine. He just like worked through this stuff, and he was always like, "Oh, you'd be surprised what you can already do. Like you'd be surprised what you can take from one field and apply to another, or what you might already know." And like this exercise is worth more than the kind of revealing aspect of it.
it's super interesting because to me, I know that doing the exercises is, I think, the most beneficial way of learning, because you just, you know, repeat what you learned. You actually put it to use into exercise. And I did this with structured interpretation of computer programs. And I have to admit, I skipped a lot of the super mathy stuff, but a lot of the other things, implement your own map, implement your own fold, stuff like this. I think that was really nice. But in general, and this is purely me, and it might be related to, school, whatsoever, but I hate exercises in books because to me, they create this weird sense of expectation and pressure. And I feel like it feels like a test to me. Oh, you read this chapter? Proof. Prove that you actually read this and that you understood it. And I just, shrink away from this. And I think I don't want this. Because the best way for me, or to get me to do something, would be not to say, Thorsten, I want you to do something. It would basically be to look somewhere else and say, it sure would be nice if someone could, or I bet nobody can do this, but hey, no pressure, something like this. And it's purely
part
me.
of his, I have the same feeling. I think because of school, because we were always given specific exercises from the book to do. A lot of the time they were bad, like they weren't actually a good representation of the skill that we were trying to learn. But part of what Balaji is saying is that, like, you're going through this process for yourself of deciding whether you want to engage with this book based on what you're going to be able to do at the end. And so if you look at those exercises and you have this recoil effect of like, I don't want to do this, or like, this isn't what I'm trying to learn, then maybe that's not the book for you. Like maybe you should come up with your own exercise and find your own resource or whatever. Or like, you look at the exercise and you see, I kind of get where they're getting at. I'm not excited about that particular thing, but I'll do this instead. Like, I don't want to write an interpreter just for fun to see if I can do it, but I want to do it as a text editor plugin or whatever. So I'm going to do that, and that's a close enough approximation, and I'll attempt it, and I'll know that I can go to this chapter as a resource, like if I get stuck.
That's exact. That would be the perfect mode of learning for me. As in, and just to stop a little bit on this part, because you said experience in school, and now that you said it, I think my problem with these exercises is that maybe it's because of school books and whatnot, but whenever I read exercises, Well, I guess I don't read them anymore. I skip them. But whenever I did read them, it was always this feeling of, you don't want the answer. You want me to know this specific thing that you try to get out of this question. It's, there might even be a trick in there where, oh, this reads like the answer is obviously this, but you wouldn't have put this as an exercise if it was this easy. So then I feel tricked. I don't know what it is. It might be because of school and my experience in school. I didn't get good grades. But everybody told me, not everybody, but a few teachers told me, you're pretty smart. You should have gotten better grades if you weren't, so lazy whatsoever. But to me, it always felt a little bit off. So my perfect mode of learning is exactly what you said. It's, for example, right now I have this itch to really understand how terminals work. Like I know just enough right now. I know the syscall, the OpenTTY, I know about the file descriptors. I know roughly what's going on, but I don't really know how it works. So my perfect mode of learning this would be somebody gives me, say, whatever, 60, 80 pages, something. Here's how to build a terminal emulator. And I would read this, but not retain all of it. And then I would go and try to build my own, fully assured, I didn't have to pass a test. Now it's all on my own. I can do whatever I want. I'm going to write a terminal emulator. And when I get stuck, I can always go back and consult the book, which is what I would do, after the first page of code. Immediately go back and look up, what did I do here? And then it would start for me where I would, put the pieces together and actually understand it.
I was
But
hoping you were going to say you would get a vintage teletype and start with that and try to make that work.
Yeah, that's also a good point, right? This, not to go on a tangent here, but I think this, especially with technology, a super interesting path, or what I always try to do is strip away all of the modern stuff, or say the fluff, and try to see what's the basic thing here. What's the purest abstraction, the purest mental model of problem solution, and then build up and see, oh, so that's why they added this. That's why they added this. So
So
from the
have you
bottom up again.
you've been working on a terminal emulator, but Ghosty, right? A little bit?
Yeah.
Okay.
Well, yeah, hacking a little bit.
Hacking a
Yeah.
little bit. Okay. But it was enough to say like, okay, I want to keep going deeper in this area.
Yeah, so Ghosty is this terminal that Mitchell Hashimoto built, and it's cross-platform, and he built the whole thing from scratch in Zig, and I was just hooked by how different it was from what I usually do. I mean, I usually do or did for the last years developer tools and systems program whatsoever, but I've never done any native development. I've never done a Swift app. I've never done a, GTK app, nothing like this. So then when he asked me would I want to try it out, I used it for the first time, and I needed this. It's called the non-native full screen in macOS, which is, I think, I don't know, from an older macOS version where the dock hides and whatsoever. And I said, I need this. And, then I thought, there's no expectations. I can maybe take a stab at this, maybe I can boot up Xcode and see if I can write some Swift and whatnot. And that's when I started to do this. But I then added some more fixes and did some stuff on the GTK side, like splits in GTK and in the Linux version. But I never got down to the core, the actual, control characters and whatsoever. That's, I kind of, again, I roughly know what's going on, but it's now my mini map of knowledge. There's like these black circles, and it would feel so satisfying to just go over there and also uncover those and see, that's what happens. And now that I work on Zed, the text editor has a built-in terminal, but it uses, because it's written in Rust, it uses Alacrity, which is also terminal emulator. And that's written in Rust. And we were getting panic reports, crashes from users, because bad file descriptor to OpenTTY syscall produced a file descriptor that was then invalid when you wanted to poll on it. And so I read through the code and realized, oh, okay, OpenTTY. So that's how you do this. And then you spawn the shell and you connect it to this. But, you know, just enough so that I'm now thinking, I kind of know where to look, but I don't know how it fits together. And that to me is the sweetest spot where you could sit down and you know exactly where to look and what to Google and what to search for and what to piece together.
Well, Aj, you always talk about this where explore your curiosity on these bug reports and these, you know, going through Sentry and like actually, you know, not just automatically muting everything and seeing if something looks interesting. And that's this amazing opportunity at work to learn. So that's cool that you, you know, have this itch and it's already something that's like cropping up in your workspace. That's amazing.
Every bug is a gift.
Every bug is a gift.
Not all of them, but
but like selfishly, as someone who's trying to learn something, every bug is a motivating example, right? It's like an opportunity to say, hey, I was wrong about something. We were wrong about something. Let's like get to a better understanding. Now, obviously, under the pressures of work, you know, you only have so much time, you're stressed, whatever. It's a shame that we don't have the ability to pursue that opportunity. But like, at least like, I mean, I wouldn't say it like that unless it was a little bit wrong, but there is something there. Like it is true that if you could modify your mentality a little bit to not get so stressed about the bug and say, hey, this is great, because if everything was going well, I would have fewer opportunities to learn about this. Now I have this really specific, motivating problem. And it's an opportunity for me to learn. Not easy necessarily to switch your mindset to that, but like people like Mitchell, I feel like are very good at this, where it's like this thing is slow, fantastic. I get an opportunity to figure out how to optimize this thing. If I were doing that in the abstract, I wouldn't care so much. But right now, I'm trying to make this thing right now fast. I'm trying to fix this bug right now. That like software engineers who can foster that mentality, I feel like are constantly learning, no matter the context. Like the task can be easy or hard or whatever. Some people will ignore a bug. Some people will like by the horns.
I feel like I love bugs. I love bugs because it's such a binary thing. You either fixed it or you didn't, you know? What I don't like is greenfield. Hey, you know, what can we do next? What's the next? You know, I don't like that because it's so arbitrary. You have to come up with things, you have to test stuff. A bug is, here's the bug report. This does not work. Make it work. It's the ultimate puzzle. So I've been now at Zed for 5 weeks and for the last 5-6 weeks. And I just hop on bugs because it's such a good way to learn too, where you not only understand how the system works by trying to reproduce it, right? That's the first thing, but also then you jump around the code base trying to figure out where does it come from. But then you also have different bugs. So you jump through different parts of the code base. And you also see which code was written by whom and why and when, and how you get some historical perspective too in the code base. So I actually really like doing this. I think the problem or the downsides that I can think of is there's some bugs that upon closer inspection turn out to not be bugs, and then you end up with, what should we do? You know, what's the desired behavior here? Is this our bug? Is this a user bug? Do we have to accommodate for them? Can we even fix this? Does this happen again? Just brush it under brush it aside. And the second thing is, Mitchell, for example, he has this, I guess, I don't know how his inner life works here, but I think sometimes you're faced with bugs where I go into this mode of, I can invest time to fully understand what's going on. Where you feel the clock ticking and you go, I spent 4 hours on this, like you said, pressure of work. I need to put a Band-Aid on. And you start to feel bad about this because there could be a good way to solve this. But And then it's all these mind games like, will I ever fix this puzzle? Will I ever figure out the right solution? Can I do the proper solution? Or do I put a solution on even though I don't fully understand it? But yeah, in general, it would be nice if somebody were to create, say, learning resource and it's just debugging. Every chapter is a bug.
That's cool.
Here, fix this. It would be a tremendous amount of work. But, say you have I don't know, you have a terminal emulator and you put bugs in it and then you ask people, hey, when I type this happens. It shouldn't. It shouldn't crash like this. You can start with crashes, stuff like this. Why is this nil? And then bit
I've
by
definitely
bit.
seen the failing unit test approach,
Yeah.
which is nice. And you get that sense of progress and things. I wanted to jump on the comment about greenfield and things like that. I sort of feel like I hear from a lot of programmers that they don't want to just be ticket takers and they feel like an automaton in some sense, and they want to be shaping the product in some way, which of course, like you can find different ways to do that. But how does that play out in terms of if you were given a project where it's like, hey, we need to build this new feature, you need to dive into that, and there's all this customer discovery. Do what's your reaction to that in terms of how you orient your work life?
It's an eternal struggle in that I think, if you would leave aside career prospects, titles, roles, whatever, all of this, maybe this is wrong, but I guess if you leave all of this aside and just think about the moment, I would be happy just fixing bugs because it's so interesting and so satisfying. And for some bugs, you can really pull out the big guns with your debugging tools and go crazy. And it's nice engineering. I like this. I like fixing things. I like making things more efficient. I like making things more, better. I like making nice things. And that's, why I don't prefer greenfield projects. But in my career so far, I also worked on a lot of these greenfield projects, and I'm also relatively good at it, at shipping an MVP or building the thing that customer wants. I have a lot of customer empathy and building the thing that actually, I don't have this engineering, I don't want to say disease, but this building something that actually doesn't solve a problem. I don't have this when it's not for my own curiosity. I get demotivated super quickly when I build something that nobody uses. That's the worst to me.
Yeah.
Which again, a bug has validation that somebody uses it, right? Otherwise it wouldn't be a bug.
Can I say something about this as well that I've been thinking about? I think that the distinction between maintenance and creation from scratch is pretty arbitrary, and the people who are good at maintaining existing systems are thoughtful about how systems should be designed in the first place. It's like, let's say you spend the first 10 years of your career doing the implementation work behind someone else's API, like you've inherited an API and you need to maintain it for compatibility, but you work behind it. Like constantly, if you're thoughtful about it, despite the fact that you're doing maintenance work, bug fixes, whatever behind the API, you're thinking about what the API has cost you, like the impact of the API on the implementation. And so when you go and design an API, you're in a better position than someone who like specializes whatever in designing the API. Like you're thoughtful about this thing. And to me, it connects with the concept of being an engineer. Like we call ourselves software engineers. We should think of what it means to be an engineer. An engineer is literally someone who works with an engine, at least originally, right? It's like the person who is running, maintaining the engine.
Yeah.
Like that, imagine tinkering with a car engine. It's like you didn't necessarily build it, but over time, engineers did build the next engine. Like engineers, the people who are maintaining the engines are building the next engine because they're the ones who are intimately aware of how the old one was breaking. To me, in software, React is such a good example of this. It's like you can have one state management bug after another and think of them as isolated things and say, hey, I fixed this. Like it was showing 300 messages in the count, but when you clicked in it, it was only showing 200 messages or whatever. How do we get this state mismatch? Okay, we fix this. Then you have another problem with another state management issue. Like at some point, if you're thoughtful about it, you say, we are having state management issues, not we are having unread message count issues. And you like step aside and say, well, what if we reconsidered how we actually declare our rendering of state? Like that's a very fundamental, really innovation, I would say, in how people started developing their front end code. And
Yeah,
well, at least innovation in the context of JavaScript, right? And that was through kind of bug fixing. Like thoughtful bug fixing led to a new design. Like that is engineering in my mind. Like not just fixing the bugs, but like eradicating them through fundamental design improvements.
I agree. I think that's a really interesting thought. Because I think, just to add another tie thought to this, innovation in my experience doesn't look like innovation from up close. It just often looks like marginal improvements. Step function is something. You make something slightly better, more efficient, and you accumulate these little steps, and then suddenly, look, we made our computer 1 millimeter thinner, and then 10 years later, look, you can now carry it around with you and it runs the whole day or something like this. And I think there's this lure of, oh, it's greenfield, it's new, we can do anything we want. And that's where the innovation is, because, an empty room and the light bulb goes on. There's the big idea. That's innovation. But like you said, to me, the engineering aspect is building something that's fit to a purpose and to the requirements with the correct trade-offs. And you won't get it right on the first attempt. So you have to kind of optimize and tweak and make it more efficient and polish here and there and move something around, or even take a step back and, like you said, say, this whole part doesn't work. Like it just, listen to this. Like that's not a good sound. It shouldn't make this sound. We have to take this part out. And then you switch that part out, and suddenly it looks like you invented a whole new thing, but it came from the steady analysis or the steady, putting your ear to the thing and tweaking it slightly and understanding it, learning with it. Yeah, I don't know, I'm rambling, but it's just,
it's the word that's coming to mind for me is integration. It's this integration of maintenance with understanding that fits, that seems to actually allow you to sort of have these informed decisions, which is a nice way to think about one's career mindset. I had kind of I don't know if this is like a fluffier question, Thorsten, but I recently went through a job search. I know you just switched jobs and things like that. And my observation of you on Twitter and with Register Spill, your newsletter, I get the sense that you love being a software engineer. And like, I imagine if you could write this book, I know there's the joy of cooking for cooking. I could see you doing the joy of programming. I don't know if that exists.
That would be nice.
But that's my perspective, and I'm just curious if that resonates with you. I personally sort of feel very lucky to have found myself into this career. But what is as you view the next X years of your career and life, like, is that love of programming seems to me from the outside to be a big piece of how you think about what you're working on.
Yeah, that's you're trying to get me to not shut up for 30 minutes, right?
No, please go ahead.
I think, yeah, I do love it. I love it, and it's. Let me order my thoughts here, but I was talking with a friend 2 days ago actually about this, and he said, "Man, I had a conversation with him a couple of months back, and he's an engineering manager. He was a software engineer before." And then he read one of my newsletters and he said, "Man, I think you kind of sparked the joy in me again for technology or developing stuff." And then he was talking about, oh yeah, this would be this and this would be that. And But then he had this thing telling him, yeah, but I also want to do this and I also want to do that. And I said, yeah, I don't have that. I like to do this. I like to get better at this. I like learning about its history. I like talking to other engineers. This is a good Friday evening for me, having this conversation. Um, and that's just now looking back when people say to me at work, you motivate the team or you bring the team together or you get others fired up. I always thought that's weird because doesn't everybody, feel this? Like, what? And then I realized it's the way I talk about things or the joy I spread or whatsoever. And to me, again, I said I don't have ordered thoughts, but I like sitting in front of a computer. I like working with computers. I like having a good computer. I think it's mind blowing that I can talk to you, one in Australia, one in the US, on a Friday evening through computers.
Yeah.
And that magic never went away for me. Sometimes I get this little blip where I sit in front of a computer on a Thursday afternoon at 3 p.m. And, it's like a lens flips down in front of me and I can see, oh, so maybe this is how others see this. They see this as I just sit in front of a screen and type characters into a text editor. But for me, that's not it. For me, it's look at the color scheme, look at this language here, look at what this other person that I'm working with, their micro decisions, look at how they debug things. Why did they formulate the git commit message this way? Why did they know this? I bet they learn it like, something like this. It's endlessly fascinating to me. And I don't know, like that's I realized last year I became a manager, engineering manager, and it was, I wouldn't say out of boredom, but out of necessity. One thing, we didn't have an engineering manager. But then I thought, should I become an engineering manager? Should I not? And somebody said, why not? Now's the best time to try it out. And I thought, yeah, it is. Because, the company trusts me, Sourcegraph. I know everybody there. I like everybody there. They trust me to do this. I don't go and search a different job and say I want to start as an engineering manager without ever having done it before. So everything was aligned. And then I always thought, but isn't there more? Like, don't I have to learn more? Don't I have to learn more? But over the past few years, people would say, Thorsten, you're the senior guy now. You're the staff engineer now. You have to teach the others. They look up to you. And then somebody said, man, like, there's not much else left. You pretty much got it figured out. You can switch to management and, there's nothing else. And over the next, what is it, 10 months or something, I realized, no, like there's this whole world. There's so many worlds still out there that I haven't explored. GPU-based programming, native programming, not even never touched games programming, didn't even come close to this, the financial stuff, all of this. And it's still fascinating. It's like, you're done playing your game, and then somebody else says, here's the expansion packs. Now you can go and do this. So now I'm at Zed and it's native app, high performance, GPU accelerated. And I'm walking around like a kid in a candy shop thinking, I get to explore this code base with really good programmers and talk to them all day long. And they explain to me how they think about problems. And I get to be the dumb guy again and ask all of these questions.
Yeah.
I don't want to say because it's recorded, but sometimes I think, should I pay them, like.
Yeah. If the founders listen this far, I'm sure they'll have a chuckle with that.
Yeah. But I don't know. This only dawned on me in the last few years where people would say this, or you would see people fall away that started with me 10 years ago. I met them at conferences. They also started programming. And I don't want to say they dropped off like flies, but they, kind of lost interest after 5-6 years and they stopped learning new things. They, became a manager or did something else or are still doing the same thing. And then I realized, no, if you just keep going, there's this whole other thing that you can breach through. And now you know, you're a senior engineer, you've done a lot of things, many times, so you have these muscles all trained. So now you get to actually use those muscles and use them in different contexts. And then you have this whole meta game going on where you think, well, I solved this problem 5 times before, but now I'm at a new company. Look how they solve it. What are the trade-offs here? How does this compare? So all of that is to say, yes, I do love this. I do love this very much. I find it endlessly fascinating. I can talk about it all day.
Yeah,
Yeah.
I love that view of you on Thursday afternoon, like over your shoulder. I'm imagining, I don't know if you played Mario 64, but there's that little
Yeah.
Lakitu guy with the little camera hanging down who's
Yeah.
always,
Yeah.
this is a video game Oz. And yeah, Oz not a gamer. I also stopped in like 1996, but he's
I was
following
gonna
and panning
say,
around, and sometimes you see him. I use this when I'm on a long run, and I sort of say, okay, imagine you're Mario and you're like the Lakitu guy going, and that helps me get into flow. But I think in your case, what's missing from that is it looks like Torsten's just staring at a screen, maybe occasionally moving his
yeah,
fingers, and you're
yeah,
not seeing that sort of mind meld flow thing. That's
yeah.
another thing Oz and I are always talking about, that the concept of flow and finding that flow. So yeah, I feel the same way. And I also was an engineering manager at my last company. I sort of evolved into that, and I've now moved back more towards hands on the machine. And it just, I'm already feeling the joy of that again. So
It's
yeah, it's
nice.
important. Yeah.
And I guess I
Charlie,
don't know. Sorry.
you go.
I I don't know if it's my age in that, you know, I grew up with the internet and you can see, you know, you can see it start to take, like, you can see all of these dreams actually happening, where when I was, you know, when a friend and I, we were 14, 15, and we would think, oh, it would be nice to have internet access here, you know, something like this. And now it's
Yeah.
everywhere. You have it on your phone. And now when I sit in meetings and there's 10 people editing the same Google Doc, and you see the cursors move around, and there's people sitting in India, sitting in the US, sitting in Germany, Australia. That's mind blowing. Like, how can you not find this magical? That this is possible, that this works this well.
Well, maybe you had to go through that evolution. And Oz, I know you had something
Yeah,
to
yeah,
say,
yeah,
but
maybe. Yeah, yeah, yeah.
because I was thinking about this with video games, because I still, in this room, I have my original Nintendo and then Super Nintendo and N64. And I had this very dumb idea where I was thinking, oh, I'm going to introduce my kids to video games in order. So I'll give them a regular Nintendo. And then 2 years later, I'll say, we got this new thing. It's Super Nintendo. Look at the graphic. And of course, that'll never work. But I don't know. And then this is
Yeah.
just the bad side of nostalgia, coming to bite me.
And I guess, you know, the other thing, I do like writing. Always, I've been a long time reader, read a lot as a kid, and reading to me is also something magical in that you can teleport yourself into someone's head, right? You write something, they sit down, they lie down on their bed, and they read what you wrote, and you have a communication with them through space and time, right? You could have written it 100 years ago or 200 years ago. And that is a fascination. Writing is a fascination. And look at programming, you know, where people say the abstraction is the machine, you know, like the code describes the actual thing. It's not just that, it is the thing, you know, the idea is the thing. There's no other thing. The idea is that you encode in text. That's the thing. Like all of these, you know, meta thoughts, these abstract thoughts combined with writing, with sitting there thinking, communicating with others, having a machine execute it, and the machine basically testing your understanding of what you put into words. You know, that's, I don't know, it's nice. It's
Yeah.
really stimulating. And the last thing, and then I'll shut up, but the last thing is I noticed when I started to pick up programming again. I programmed as a teenager, then I stopped and tried to become a musician and play guitar. And I would say I did have a knack for guitar, or I got compliments and whatnot. But when I then went back to computers and started programming again, I realized I can practice programming all day long. I can practice sitting in front of the computer and doing something with the computer all day long. I don't like practicing the guitar.
Mm.
But sitting in front of the computer and trying to figure out why this does not work, this app, I can do this for 8 hours. Like it's not a issue to me. It's not that you don't need to motivate me even. If you give me the bug and say, why doesn't this start up? Can you figure this out? I will have all the motivation I need. And then I realized maybe this is my poison, you know, maybe this is the thing that I should do because I do enjoy getting better at it and I don't mind the practice. And I think Jerry Seinfeld had a line on the Tim Ferriss podcast. I wish I could quote it, but he said something along the lines of um, everybody, you know, has their own poison or their own pain that they can endure. And you have to find the thing that you can endure. And for comedians, you know, in his case, I think it's writing is hard, going on stage is hard, bombing is hard, not having a bit that works. But if you found this to be your poison, then you're hooked and then you try and get better at it. And for me, it's, you know, sitting in front of computers and trying to get better at programming.
Yeah.
To what degree do you think that this is encoded in a person? Like, are they born with it? Do they develop it at 5? Is it a function of their first work experience or something? Like, to what degree is it malleable, do you think?
I think now having, you know, I have a 6 and a 2-year-old. I do think there's something that you're born with in that. My older daughter, for example, she has no interest in figuring out how stuff works. Like you can install, we installed the AC in her room and she didn't notice. She's like, oh yeah, there's another thing. My friend's son, he came by and he's like, what is this? Where does this wire lead? Let's go outside. I want to check this. How does this work? So what does this do? Where does it do that? Where does this come from? Why does it only do this? He's the guy who picks up the remote control and, oh, I got it figured out. And that was me as a kid. This, you know, back then they would sit me in front of a computer with Windows 3.1 or DOS or whatever, and you just type like, oh, here, look, I can change the prompt in MS-DOS, and just sit all day there and try and figure out how this works. So I would take my toys apart and see whether I can, you know. And I don't know where that comes from. I don't know. But I do know that, you know, my parents encouraged me, yes, please use the computer. They didn't encourage me to get a video console. They always said no video consoles in the house, but you can use the computer. And then I realized
But you can get games on the computer.
yeah, well, that too, but also early on, I realized that this is a level playing field because I'm 8 years old and my parents asked me for advice on how to do something with the computer. And you realize, oh, you know, I can get better on my own with this. And then it's just, you know, went from there. But I don't know. I would say you have something, but I think that one thing is your unique perspective on it. And I think that can be different for a lot of people. I think there's some fantastic programmers who have a completely different view on programming and computers than I have. And they wouldn't, you know, for me, a good Sunday morning would be to tweak my dot files, whatever. I like that, you know, or setting up a Linux machine or Raspberry Pi, whatever. For others, absolutely not. They don't care about any of this. They don't have a fascination with that. They do have a different fascination, which is abstract thought, math, whatever. So this bit is interchangeable, but then I think apart from that, you have to kind of put things within reach for that thing to hold on to. And for me, it was computers and the rise of the internet and the excitement, you know, like the late 90s, you know, every 4 weeks there was a new, faster CPU coming out, you know, TV commercials for the new Pentium 3. whatever.
This is why
So
the
I don't know.
Matrix said they picked 1999 as the optimal time
Mhm.
for humanity, and that's why they were looping in that time, I believe.
Do they say that in the movie? Yeah.
I'm pretty sure. I certainly 20 years later when the robots took over, that probably wouldn't have been ideal to be running in the
Yeah.
simulation. Gang, I gotta run.
No worries.
But this was amazing. Thorsten, we'd love to have you back on. I feel like I want to pick your brain on Oz and I have been mulling over some things around like what a stripe press for kids would look like.
Oh yeah,
Again,
yeah.
I think that'd be really fun. But this was great.
Cool. Yeah,
Thank you.
this was a lot of fun, man. I could have talked for longer than this.
Okay.
Appreciate it.
We'll be back.
All right.
All right.
Bye-bye.
Bye-bye.
Thanks, guys.